All right. When you hear artificial intelligence, what's the first thing that pops into your head? Probably something about shiny labs, right? Maybe Silicon Valley? What we're going to do today is pull back the curtain on the secret history of AI. And trust me, it's a story that started way before anyone even dreamed of a computer.
So, let's get right into it. Where do you think AI really began? If you ask around, most people would probably say, I don't know, the 1950s? Maybe the early days of the internet? But what if I told you that to find the real starting point, we have to go back way, way further than that?
Yeah, you heard that right. The dream of creating artificial life is literally ancient. We're talking thousands of years ago, with Greek myths about figures like Talos, a massive bronze giant, an automaton built to guard an entire island. Now, obviously, this wasn't science, not yet. But it was that first spark, the first time we asked, what if we could build something that thinks?
And that's where our story really begins, with this ancient dream. Long before anyone had the tech, you had philosophers and poets and storytellers all wrestling with this huge idea. What does it mean to create a mind that isn't born, but built?
Okay, so to make that dream a reality, you need more than just good stories. You need tools, but not just hammers and chisels. You need tools for thought. Before you can even attempt to build an artificial mind, you first have to figure out how to mechanize the process of thinking itself.
And if you look at how this evolved, it's just incredible. It's like a series of building blocks. We start with the abacus in ancient China, basically the first step in mechanizing arithmetic. Then fast forward to Al-Khwarizmi, who gives us these step-by-step procedures, the very idea behind algorithms. From there, you get Pascal's mechanical calculator, and then a huge leap with Jacquard's loom, which used punch cards to automate weaving. That was the first programmable machine. And all of this leads to the big one, Charles Babbage's analytical engine, which was, for all intents and purposes, the conceptual design for the very first general-purpose computer. But the machine was just a concept. It took a true visionary, Ada Lovelace, to see its real potential. She looked at Babbage's engine and realized something profound. It wasn't just a number cruncher. It could manipulate symbols, anything that could be represented by a symbol. And with that insight, she sat down and wrote what is now recognized as the world's first computer program, an algorithm designed to run on a machine that hadn't even been built yet. She was literally seeing the future of computing 100 years early.
So we've got the hardware ideas, right? The gears and the mechanics are starting to come together. But that's only half the battle. Now we need the software, the theory, the blueprint for a mind. How do you even begin to design a thinking machine?
Well, the master blueprint arrives in 1936, thanks to the one and only Alan Turing. He came up with this theoretical concept he called a universal machine, and the idea was absolutely revolutionary. He imagined a single machine that, if you gave it the right set of instructions, the right program, could solve any problem that was solvable by computation. This wasn't just a souped-up calculator. This was the fundamental idea, the bedrock for every single computer and every AI that would ever be built.
So if Turing gave us the architectural plan, then McCulloch and Pitts gave us the Lego bricks. In 1943, these two came up with a mathematical model for a brain cell, an artificial neuron. Just think of it like a simple light switch. It can be on or off, 1 or 0. And what they proved was that if you wire a bunch of these incredibly simple switches together in a network, you could get them to perform really complex logical tasks. This was huge. It was the first time anyone had made a concrete mathematical link between the squishy biology of our brains and the clean logic of computation.
Okay, but a network of switches is one thing. How does it learn? That was the big question. And the answer came from a psychologist, of all people, Donald Hebb, in 1949. He proposed this beautifully simple rule that you've probably heard. Cells that fire together, wire together. Basically, if two brain cells are active at the same time, the connection between them gets stronger. That's it. That was the missing link. A simple, powerful rule for how a network could actually learn and adapt based on experience, just like our own brains do.
All right, let's take a breath. The stage is officially set. We have the ancient dream pushing us forward. We have the mechanical tools for computation. And now we have the theoretical blueprints for a mind. All these different threads, spanning thousands of years of history, are about to come together and spark the birth of a brand new field of science.
And who else but Alan Turing to kick things off again in 1950? He basically threw down a challenge. He proposed a test, which he called the imitation game. The question was simple. Can a machine hold a conversation so well that a person on the other end can't tell if they're talking to a human or a computer? This became the ultimate goal, the Mount Everest that this new field would set out to climb.
And that leads us right here to one single pivotal year. This is the moment. The summer of 1956. A small group of absolute titans. We're talking John McCarthy, Marvin Minsky, Claude Shannon. They all get together at Dartmouth College. And their goal was, well, it was incredibly ambitious. They wanted to figure out how to make machines that could think, reason, and create. And it was right there, during that summer workshop, that John McCarthy gave their new field its official name, artificial intelligence.
So now it has a name. It has a mission. The field of AI is officially born, and it's ready to get out of the world of pure theory and into the lab. It was time to actually start building things. Time for AI to take its very first steps.
And one of the first big steps was a game of checkers. In 1962, a program created by Arthur Samuel went up against a human checkers master. Now, the amazing part wasn't just that a computer could play checkers. No, the mind-blowing part was that the program learned. It got better by playing games against itself over and over. This was really the first time the public got a glimpse of what we now call machine learning.
Next up, in 1966, we meet Eliza. Eliza was the world's first chatbot. It was a pretty simple program, really. It pretended to be a psychotherapist, and it worked by just spotting keywords in what you typed and turning them back into questions. But people were fascinated by it, and you can draw a straight line from Eliza to every single chatbot and virtual assistant we use today.
And to cap off this whole incredible first decade, we get Shaky the robot in 1969. Now, Shaky was the real deal. This wasn't just a program on a screen. It was the first mobile robot that could actually look at its surroundings, reason about what it saw, and then make a plan to carry out a task, all by itself. It combined computer vision, planning, and movement into one autonomous package. It was a huge breakthrough.
So think about that journey. It took us thousands of years to go from the myth of a bronze giant to having the first real blueprints for an artificial mind. But it took less than one generation to go from those blueprints to a robot that could see and think and act on its own. They built the entire foundation of modern AI in an astonishingly short time. Which leaves us with a pretty big question. They built that foundation. What are we going to build on top of it?